But as Brian said, this is the agenda. This is not my bio slide. But I work with these guys at MongoDB. The fellow in the middle is Bajori from he basically keeps PHP.NET together. And the guy on the left is, if you've ever used PHP's datetime component or xdebug, you can thank Derek Rethins for that. So they're both excellent mentors to have. So I'm lucky to be on part of that team. But aside from that, that's just on the MongoDB side of things in the driver. But I also work with these guys plus more, which I couldn't all fit in the slide. These are just the various contributors to all the different Doctrine projects. And in the top right with me is John Wage, who works at old company I was with, OpenSky, and we basically work on the MongoDB Doctrine stuff together. But let me jump back to the things that I want to talk about today. So I'm going to talk a little bit about the Doctrine project. But before we even get there, I want to take a tour of various database design patterns to familiarize yourself. So we're going to pull some examples from what's been in Zen framework for a long time. And that made Adam perk up. And then we're also going to look at ActiveRecord, which hopefully a lot of people have heard about, maybe not with PHP, but with like Rails and other things. And then look at where Doctrine comes in nowadays. And then once we cover all the design patterns, we'll have a basis to introduce what Doctrine 2 is. So a little confusing just to get into it. There's the old Doctrine 1, which was an ActiveRecord style. So that was going back about 5 or 6 years. And we'll cover a lot of the history. But Doctrine 2 is what is the object persistent stuff I'm going to talk about today. And for the non-ORM stuff, for MongoDB, there was no Doctrine 1 for that, so we just call it Doctrine. But we're going to be talking about that. And then at the very end, it was some of the stuff in the abstract. Outside of all the database stuff in Doctrine, there's these other libraries that we support. So something that's showing up in a lot of frameworks today, even that have nothing to do with databases, is the annotation parsing for PHP annotations. So that happens to be one of the Doctrine projects. We also have something like for just caching, for doing lexing and parsing and stuff like that. So those are some of the libraries we'll talk about after. But to introduce the Doctrine project and where it fits in the history, so how many people remember some of the things at the top of this list or have worked with them? Maybe you're still working with them. So we all trace our roots back to Pair, and then there was this other metabase library that was going back maybe like 10 years ago. That was what we had to work with databases in PHP if we didn't want to just use the MySQL functions. And then from there, we had this MDB library, which got a little bit better. And then, which is, I think, kind of still maintained, is the version 2 of the MDB library. So those are still available in Pair. And then around this time, maybe 5 or 6 years ago, there was ZenDB. And that was a database abstraction, which we're going to talk about in some of the design patterns today. And after this, that's where Doctrine ORM came in, the first version of it, and it kind of pulled, so some of the code in Doctrine ORM goes back to some of the old MDB code. There's probably some snippets and some contributors there. And then within the last 4 or so years, with all the PHP 5.3 frameworks and things popping up, this is where we get the ORM version 2 with some of the nifty features we'll talk about. And then instead of, if you don't want to use an ORM, you just want a database abstraction, that's a separate component, which the ORM also utilizes, called dbal for database abstraction library. But talk about some of the design patterns. So how many people are familiar? I know Laura mentioned this in her opening talk, just the terms of design patterns. So how many people are familiar with those? Hopefully you're using some in your applications. But this is, a lot of design pattern talk comes back to this book from Martin Fowler, which I think is from 2003. And he goes over not just database design patterns, but things like introducing the dependency injection and different like the singleton pattern and other things that you don't want to implement. And he basically covers the full spectrum of patterns of designs that you would have in your, in any, not even an enterprise application, but just in software engineering in general. So to introduce why we look to why design patterns should apply when we're dealing with databases, with very modest Googling, you could pull up examples like this from the W3 fools on basically working, and this is, I mean, this is one thing to where this was basically in Laura's talk going back to like 2001, 2003. And this, you'll find plenty of this in the PHP.NET documentation too. And it's not to say, maybe in this particular example, it could be pretty messy. You could certainly use these functions and use them responsibly. It takes more effort. But if we say filling in data from a form, and this goes back to like building up your SQL strings and just injecting variables in them, and it's very easy to shoot yourself in the foot. So that is a great lead into why you might need design patterns in your database. So the different data source, the different patterns that I want to go through, and they all kind of build on top of each other in terms of complexity, are originally the data gateway patterns, and this is what ZenDB still provides. And then top of that, we have ActiveRecord, and then what Doctrine 2 and things like Hibernate and Java implement is the DataMapper pattern. And as we introduce these, we'll talk about we'll look at the PHP interfaces for like what constitutes a gateway, or what constitutes an ActiveRecord interface, and then take a look at, well, what are the reasons we might want to build something more on top of this. In Doctrine's case, we left ActiveRecord to go to DataMapper for a lot of it was performance and scalability reasons. So to introduce the gateway patterns, and I'll do a little quoting from Martin Fowler's book here. So a gateway, the general definition of a gateway is just something that encapsulates access to some other service or resource. So in the case of a table gateway, we're going to abstract our access to a database table. So in your mind, you're thinking at the very least, this is going to be the access to do the queries against the table and maybe do all the writing back to the table. And so if I'll pull up, the example here is going to come from Zen's table gateway interface. And so for just working with the database table, we're going to have this one instance controls all of our interactions with this table. So in any application we'll probably have one table gateway for each model that we have if each one is a separate table. And the relationship that we have here is we'll have our model on the left, and for now we'll just say it's a class. We're not going to get into how to model that exactly right now. But the gateway class is going to have certainly the methods to do the reading back. So find, we might have find with some criterions. And we still use things like this today in Doctrine. It's nice to have a method that says like find one by username, say in your user repository class. And then we also have the methods for doing the writing back to the database here. So in this case, we're updating. The gateway here doesn't, even though there may be a model, the gateway doesn't necessarily interact with it. So when we're updating, we're actually writing all the fields back to the table, because we're not abstracting the model here or whatever the object is in our application. We're just abstracting the SQL table. So there isn't that. It's not as pleasant interface as having a model and being able to just save this model to the database. And so if we take a look at the interface out of the Zen classes here, so we have getTable, which probably just returns a string name of the table. But we have the finding method with select with some where criteria. We can go insert and update our data back, and then we have a delete method. So this is pretty straightforward. It does a little bit of abstraction for us, but it's not too much. And then the row data gateway kind of narrows this down. So in this case, we're just abstracting a single database record. So we're going to have a gateway, but now it's just going to control access to a single row. And so this brings us a little bit closer to when we think of ActiveRecord, where every model is responsible for saving itself to the database. So in this case, we have this individual gateway to write a row back to the database. And so the interactions here, we would need the gateway now only has basically the writing methods. And to be able to find ourselves, we basically need something to give us back the row. So we need this new finder service. And we still have things like a finder today in Doctrine and other libraries. In Doctrine, we call it a repository class. So that's going to be the thing that does the actual querying for us. And so this is really just breaking the table gateway into two separate components. In like perusing the documentation of, I think ZenDB's documentation isn't terribly, I mean, it's been maintained, but it's not up to, they don't really push these as, you definitely want to use these in applications. They're kind of leftovers from what they've had for many years. But the row gateway here is really, we still have the same person model, or that could just be an associative array off to the side. And so the interface is really just a subset of what we get with a table gateway. And so the finder class is definitely something you have to implement yourself. It's not even included in, there is no interface for a finder in ZenDB that I know of if you're using row gateway. But a few problems with the gateways is that they're certainly design patterns. They're maybe better than using the raw SQL functions, but they're really just thin abstractions, and they're not really doing much for us. It doesn't cover anything about the data model. So when I refer to the person object off to the side, even though we're probably all tempted to say, okay, that's obviously a class with the ID, the first name, the last name properties. But it's not actually covered with, the gateways don't know how to interact with models. So in that case, the issues, the two things that we have to go from what data looks like in the database to what it looks like in our application in a class would be hydration and persistence. So going and taking the data from the database and turning it into a PHP model would be hydration. And then going in the opposite direction of taking my model and storing it in the database is persistence. So that isn't included in this design pattern. There is there's a component, DataMapper component in Zen framework for doing that, but you kind of have to plug it in yourself. And so this brings us to ActiveRecord, because we'd like to have something a little bit more usable. And this is what you'll find in Doctrine ORM 1. There's also, if you're familiar with Propel, Propel implements this as well. And the examples that I'm going to pull from are from a PHP, it's just called PHP ActiveRecord. So with ActiveRecord, we have an object that it still wraps a row in the database, but it encapsulates all data to that. Basically everything, including the writing it back to the database, reading it from the database, and all the business logic as well. So this is where we bring our model to the game. And to go back to ActiveRecord, this is DHH, the author of Rails. So he was really responsible for making this, and he did a lot of little diagrams for Martin Fowler's book on ActiveRecord. So this is probably one of his diagrams here. So with ActiveRecord, we go from having the separate gateway services or objects in our class to just having the person model. And now the person is responsible for for saving itself or updating itself. And then also the find methods aren't covered here, but usually what we'll see in an ActiveRecord implementation is having static methods in the model class that actually are responsible for finding and giving you back a person or finding multiple persons back to you. If you're using Laravel, it's probably a facade or something like that. And then additionally, with the database, the insert, update, and maybe the find methods might be here. We have all the typical business, or we'll call it the domain model logic that you might want to have on your application. So maybe, in this case, is flagged for audit might actually check some of the properties inside of a person and return true or false. So this has really everything to do with your domain model in the application, really nothing to do with the database side itself. But when you're using your database objects in the application, you have certain business rules and logic around them. So you'd like to put them in your models. So with ActiveRecord, we're sitting on top of the domain model, in opposed to having a row gateway or a table gateway and just having to work this other interface to send data back. So ActiveRecord can do the persistence and the hydration for us. So it basically gives us where row gateway, the models are capable of saving themselves and updating themselves, and we can add in all the business logic on top of that. And the transforming the way the data looks like to get it into a model. When I talk about the domain model, it's at the very least, we'll say four basic components. Maybe validation is optional. But it's responsible for encapsulating any of the stuff in our database that we actually care about in our application. So it'd probably be every database field has maybe a one-to-one mapping with some field in the domain model. And then the business logic methods, so things that are maybe calculated results or making sure that if you're setting a full name or a last name that you're doing some kind of making sure that it has two string components or something like that. Modeling any relationships between, so maybe persons have multiple addresses, and in your database, you might have a join table or you just might have a has many relationship, or you have a separate address table that calls back, each row has a person ID. But when you're working with your person model, you just like to say, get me all my related addresses that I have in my account, or all my shipping addresses or something. So having those relationships tracked in your domain model and also having something like Doctrine or ActiveRecord handle the relationships for you makes working with your models much easier. And then the issue of validation, which is debatable whether validation lives inside the model or in Symfony's case, they have like an extra validation component, which will then look at a model and determine if it's valid. And some people, on the flip side, you might have methods in your model class that if you try and set a full name or set an address that happens to be invalid, you'll just raise an exception there. So there's different places to add your validation. But all this stuff has really nothing to do with the database necessarily. Your relationships could exist outside the database. But it's the job of the DataMapper layer to be able to translate this into the table relationships. So when we add ActiveRecord, we have, one, we need some way to create these objects back for us. So if each object is capable of saving itself back to the database, in addition to whatever fields exist on it, it probably needs some reference to the database resource or some connection inside. Some service has to be there so it's actually able to write itself out. Additionally, if we have these find methods or these query methods on the model class, we need some logic in there to be able to do the hydration, to be able to turn the associative array that comes back from the database driver and turn that into an actual object with the appropriate fields hydrated. Additionally, on the flip side, the persistence is taking whatever fields and changing them into what it may look like in the database. So if I have, in my model, I might actually have an array of address objects in my person. If I'm working with a relational database, I can't just stuff an array of other objects inside a database column. So persistence logic would have to take care of breaking it out and storing multiple addresses to some other table, and then storing my person into its own table. And maybe that persistence logic changes if you're using like a document database, where you do have the flexibility to do that. And additionally, just like we have where row table gateway needed your own finder service, and there you can have your own custom methods defined by certain criterions. So with you might have your common queries in ActiveRecord where the same things that you'd expect in a finder or repository class. And then there's the familiar CRUD methods, which are just create a new object, find one object, update, and delete. So those are things that were in the table gateway, and we need them basically to work with any database entity. So an example in PHP, and this is so not to slam Doctrine on every possible slide. This pulls from the PHP ActiveRecord project. So this uses statics to actually create and instantiate the objects. And so what we're not seeing here is somewhere the user class was initialized with some internal database context. So probably from the initial, when we configured the application or we bootstrapped everything, it injected something into there so that the user knows how to query for these things. So user create, basically constructing a new user object, and we'd want to use this instead of just doing new user because we need that user object that comes back here, we have to be able to save that. So if we were just using the default constructor, we'd either would have to pass in some database context or we'd have no way to actually save ourselves or update ourselves in the database. So you'll probably see a factory method to create new instances with ActiveRecord. Additionally, when we're querying, that also is going to be done through in this case, a static method, something that has the database context because it has to do the query for us. And we might have a lot of libraries like to use __, I think it's call to basically, they might have a find one method and a find all method, and then overload the PHP method operator so you can kind of create your own method names, and it would kind of infer what the criterions are for this. So over here, a call method, there might not actually be a find by name, but it just looks for the syntax and it knows, basically constructs a find call where name is Tito. And then updating, the documents are responsible for saving themselves and then deleting themselves. So that's all pretty straightforward. So the problems with this, and you can go certainly a long way, Rails is so popular because it's so easy to pick up. ActiveRecord is very easy to work with, very low barrier of entry, and you can get a lot done very quickly. But it reaches some of the problems that it hits, and this leads into introducing what Doctrine 2 tries to overcome. So the first one is the single responsibility principle, which, to summarize, is basically you do one thing and you do it well. So in the case of, with ActiveRecord, we have one model essentially doing, internally at least, that's doing all the hydration, all the persistence, all the querying logic is in there, and the data modeling, and our business logic, and maybe the validation in these relationships and things. So it creates a very large bit of responsibility in a single class, or even if it's probably, in most implementations, you would have some base class that does all the grunt work, and your models, you don't have to think about it. But that also leads into testability, because now if each model basically doesn't exist without a database context, so how do we write simple unit tests for our business logic, really, which has nothing to do with the database, or our modeling, doing things like validation. To be able to work with these models, we need to fetch them from a database or have some database context. So having, basically coupling our database with our models causes testability issues, because now we really can't write tests without having the database available or mocking it out. And so we'll contrast this in Doctrine 2, where we can use our models can just be plain PHP objects with a bunch of properties and no stuff underneath. And then there's a second issue is multi-tenancy, which is basically a application that might have multiple websites or multiple databases. So if every model is responsible, we create a model and then we save it back. Nowhere were we specifying what database that we're writing it back to or anything. So this is an issue if you want to have models that can be stored to multiple databases. With ActiveRecord, there's, at least in the basic implementations, there's no way to specify that, yeah, this is actually meant for another database or a separate application. So you have your models are basically tied to a single tenant or a single app. And then the issues of scalability and performance. With the notion of scalability, when it comes to models having to save themselves, so if each model has a save method, how do we, if we have to save 5,000 models back to the database, we're doing some kind of batch update. And we'd like to use ActiveRecord for this instead of writing that SQL update where and update everything. We'd like to use our model mapping layer to do it. So whether we're having multiple, whether for each loop where we're calling the save method like once for each document, there's really no way to, with that API, batch them all up and to do some efficient database operations. And then when that leads into performance as well, when each single model in our application has the same boilerplate stuff underneath and all the same resources and copies of these things, even with PHP intelligently managing references to objects, it makes our models a lot larger than they would otherwise be. Because they have all those extra methods, all the extra logic underneath them. And so for much larger applications, and this is what some of the Doctrine developers faced in their using Doctrine 1 at their companies, they reached points where they were hitting memory limits or hitting too many database queries. And so the issue of scalability and performance with fat models eating memory, to go back to, and a lot of the ActiveRecord libraries were from a pre-5.3 phase. So before 5.3, the garbage collection was not there, essentially. So we'd create these models, and even after we stopped using them, we would have all this memory left over. And then with 5.3, we get much better use of this when things go out of scope. Garbage collector gets picked in, and we go back down in memory. So that's very useful if we're doing these long-running batch scripts and things. And some of the other functionality that was added for in 5.3 was SPL object hash, how many people are familiar with that? So just being able to, so every object in PHP has some unique hash, like the resource ID or just the memory location. And so in newer versions in Doctrine 2, we'd like to be able to track database objects, and we need some unique way to identify them. Because we might have user models. If we're in a multi-tenant application, we might have users or people with the same identifiers, and they actually live in different places. So with using an SPL object hash, we can keep track of unique objects inside of our application. And then some of the other, Guillermo Blanco is one of the Doctrine developers, and he wrote a number of patches to 5.3 to make SPL object hashing a little bit faster, and then some of the things that we do with reflection. So the reflection API in PHP is basically allows us to just look at a class, look at an object. Maybe it has private properties, maybe it has protected properties. As an ORM, you might want to actually go in and tinker with those values and set them if you're doing things like hydration or persistence. So we need a way to actually get in there and do that. And so that was some of the, in 5.3 we had a lot more access to do things with reflection. When you're developing a domain model, it's good practice to not use public properties for everything. Put things behind getter and setter methods, and then test those methods. But in the ORM's case, we basically, certain properties correspond to certain things in your database application. The ORM may not want to use a getter method that incorporates your business logic to send data back to the database that needs the actual value inside your object. So how do we get that out without using the reflection to go in and actually pull out the value? So that was one of the other benefits of 5.3 that makes Doctrine 2 possible. And so this brings us to the fourth pattern, which Doctrine 2 implements, other ODMs do, and it's referred to as DataMapper. And so the DataMapper pattern is constructed of, we have these mapper services, and they're responsible for transferring the data to and from the database. And basically the objects and the database layers get to remain completely independent of each other. So this is good. It keeps, we now have separate services. The models don't have to know that they're stored in the database. the persistence layer doesn't really have to know anything about the model. And it leads to smaller, more decoupled code. So in the DataMapper case, if we have our person model, and now the person's not responsible for saving themselves or querying for themselves or anything of that nature, we have this mapper that is responsible for doing all the I/O with the database. And then what's not here is we'd still have another class maybe to do a repository, to do the find methods. Maybe that could be integrated into the mapper. But we have this independent mapper service, writes to the database, and then we have a model that doesn't really have any awareness or doesn't really care that it's connected to a database. So to contrast this with ActiveRecord, where we took our data model and we augmented it and stuffed other functionality in there, maybe we hid it underneath. With the DataMapper, we're just complementing it with another service. So we can work with these simple model objects and then use a mapper service to get them over to our database. And we have two completely separate and testable things. And so the mapper is going to be responsible for the hydration and persistence, which in ActiveRecord was stuck inside of our model, and then in the gateway it was a separate component that we'd have to handle externally. And so the end goal here is that we're just taking these in-memory objects and we're distinguishing them from the database. So it functions as that boundary. So this achieves a few good things for us. The first is a separation of concerns. So we now have separate components that are responsible for their individual tasks. So we can test for them. They have a lot less code in each file. We could have smaller interfaces that define exactly what they do. And then the in-memory objects also don't need to know that there is any database persistence there. So that's great for testability. And testability is important because Chris Hartjes says so. And he can go on to this tomorrow in his talk. So an example of what this all looks like in PHP. So instead of using factory methods to make our models, we can just construct the objects, use setters to set our properties. And now we have this manager that's our mapper here. And so when we say manager persist, I'm saying you're the manager, you track all the database objects, so I want you to start tracking this user object. So this is going to be some model that doesn't even know about you, but I want you to start tracking it to ultimately save it to the database. So when we persist a new user, it doesn't have any identifier, it doesn't exist in the database. When we can persist multiple things, but until we call flush, that's the first point where we actually do the transaction or we interact with the database. So the benefit here is if we persisted multiple objects and then we flush them at once, the manager can construct an efficient database query and go insert, do a batch insertion, or update multiple things at once.
The flush kind of like a commit?
Yeah. So in a relational model, the flush would be like a commit. In the Doctrine MongoDB model, it does a bunch of independent database queries. But until you do the flush, nothing actually happens. And so it gets around the issue that we had with doing like large batch operations where you have like thousands of models and you want to, as optimally as possible, send them all over to a database. And so the other benefit of this, which may not be so easily apparent though, when we work with the manager, and here just to keep the manager simple, we have a separate repository that has all the find methods. So we get a repository, which is like our old finder class from the row pattern gateway. And that would have the similar find with some criteria methods. So when we query for a user or query for some model through our database, it comes back to us already managed. So there's no need to persist it anymore. So that means if we get this user object back, we got it through the manager class. And now if we make any modifications to it and we flush that, we can rely on the manager it knows what actually changed in the user object. And so this should construct a SQL query where we just update that individual field that changed. So we're not writing the entire user object back to the database. We're just doing whatever the small change set may be. Or think of it like version control for entities. And then finally, removing, that's all also done through the manager itself. And so with the DataMapper, we end up getting a lot simpler model classes, which are really portable between, if you were using another DataMapper, your model class would theoretically stay the same because it's just your business logic and whatever properties you care about. The manager does all the persistence for you, and if you have custom query methods, we could put those in a repository. The other benefit here is multi-tenancy. So whereas with ActiveRecord, the models are responsible for saving themselves, in this case, our models don't care about the database. So we can reuse the same model with multiple databases. just by having different managers for multiple sites or databases. So one interesting way we use this, since there is Doctrine for SQL databases and Doctrine for MongoDB, at an e-commerce website, we had a single model that had mappings for MongoDB and mappings for SQL database. And so we had the manager for MongoDB, the manager for SQL. We can use the same model, persist it into a relational database, and then also persist it in a MongoDB database. And maybe one was the authoritative one. We would use the SQL side for doing any transactional stuff. And then Mongo was more like a backup for some of those objects. But even if you're just using all relational databases, having, think of a project that services multiple domains, multiple or separate databases, having one model and being able to have managers for the individual websites. If you're doing something like a batch job where you have to migrate everyone's data, you could just work with managers from each client and then persist the models independently. And the end goal is your model class stays the same. And creating that extra manager, if Doctrine is doing its job right, is just a small little bit of configuration. So the other benefit here, which touched on with the flush method, is scalability and performance. So if we're dealing with thousands of model classes, or model objects, the classes themselves are a lot smaller. They don't have anything hidden underneath them. So they really are just consider them like value objects with maybe our custom business logic methods. And then in terms of performance, when we flush, the manager is able to batch things together and kind of work with the database as efficiently as possible. And then if there's issues with where there's like dependency chains where we have to insert, because maybe foreign keys, we have to insert certain relations first, the manager can do that on its own and do that inside of a transaction. One of the issues with when it comes working with, so in a relational database, we have ActiveRecord, and you were saving, say, the user responsible for saving themselves, and as well as any of the related documents, or sorry, the related objects. So a user, you do user save, and it actually has to save all the addresses as well, or all the accounts, anything that might be related to the user object. So that's one thing in a ActiveRecord implementation, but when we work with, working with non-relational databases, dealing with all those relationships might not be able to happen inside of a transaction. And worse, it could be our single model might contain things from multiple. We might have an embedded object inside of our, the address might not be a relation. It could be stuff within. So when we're dealing with ActiveRecord and basically a model saving itself, think about the saving itself might not involve just working with one table. It can involve working with multiple tables or databases. So this is where dealing with a manager that's able to batch things together and prepare separate updates or insertions to various databases becomes much more useful. So object persistence looking, and this is going to be a look at what the interfaces are. So working with the ORM or the various ODMs. And so a lot of the API was inspired by, PHP likes to copy Java. So a lot of it is based on Hibernate in Java. So the basic architecture, and these are the high-level components. Some of these are actual class names, and some of them are just interfaces. So the things at the top are what is depended on by the things at the bottom. And as a developer, you'll find yourself working with the bottom three most of all. So at the very top, we have the metadata, and this is the stuff where you can, your PHP models need to have some metadata associated with what do they look like inside of the database. And you might do this with annotations or XML files or YAML files. So the metadata is just your mapping information, and that's used by the hydrator, basically to turn our database response into a model, and then the persister to send it back. So they obviously have to know about how fields are mapped. And the unit of work uses both of those, and the unit of work is really what tracks our objects and does all the change tracking for us. So that's really the brains of the operation here. Event Manager has really nothing to do with databases itself. It's just a standalone library that we use for events. So if you want to listen on when, say, user objects are persistent to the database or flushed to the database, you can register an event listener, and it'll get triggered when you'd expect it to. And the three at the bottom, what we most interact with, the Object Manager is where we're doing the persisting and the flushing. So your application definitely works with that. And then the repository is where we'll collect our query methods there. In addition to the repository, we'd have a query class, which is more like a query builder. So kind of like a Fluent interface to build up chunks of queries, whether you're dealing with SQL queries or there's a query builder for MongoDB queries, and they kind of have the same interface. So it kind of looks like, reminds me of working with jQuery years ago, where you can say, get a query builder for a user, and then say chain to the field method, where field username, next method is equals, and chain things like that. And at the very end, just say, get me my results. And so a look at what the metadata looks like, and for the easiest way to get up and running is just to use annotations, and at least get used to them. If you're making a library that you end up distributing to people, the advice is probably not to use annotations, and because it gets coupled to the code. But then you would use something like XML or YAML in case people need to extend them. But for your own personal applications, if you're the only one using your model files, it's very easy to just go ahead and use your annotations. Yep.
Is there one that's most common?
For metadata?
Yeah.
Yep. So at least in the Symfony community, the advice is if you're redistributing so there's like the bundles or the plugins that sometimes have models. So over there, use XML and use YAML files, because then people can either disregard them or include them and override them. With annotations, if you're shipping classes, it's much harder to kind of like undo an annotation in a parent class. But for inside your own application, I think these are probably the best option to use. And it also makes the code more self-documenting. Because when annotations had not yet caught on, it was basically juggling. I would have to have the XML or the YAML mappings open in one IDE and then look at my model classes in the other and kind of keep track of things. Whereas here, it blends in nicely with if you're doing PHP docs and stuff like that. So here we're just saying that the product class is some entity in our database. If we're using an ODM, it would be a document, which is just a bit of nomenclature. And then we say what the default table that we'd like to store these are in. Notice that we're not specifying the database here, which is beneficial because that's really up to the manager to decide where things are stored. And then the ID property, I'm not showing any of the getters or setters or the constructors here, but the ID we're going to say that is the ID of our object. And Doctrine needs to know what the identifier is, because that's how we're going to be able to track objects. We want to keep track of database objects inside of the unit of work so that we can track changes to any product with a certain ID. It's going to be an integer that's auto-incremented, and this abstracts away where in Postgre it might be a sequence, where in MySQL it might be an auto-increment column. So that's left up to the dbal library to do. And then we'd have our other fields as well, annotated. And so the hydrator is going to take the metadata, and when it gets that result from the database, be able to turn that into a product or a person object or whatever our class may be, and the persister just goes in the opposite direction. And the unit of work is really what's doing all the change tracking. I would encourage you not to go look inside. It's pretty messy code. A lot of it, if we wanted to embrace design patterns, we could split this up into lots of separate little components and call things. But for a lot of performance reasons, we have to decide, well, it's better not to do function calls because this is running hundreds of times when we're doing a flush. And so we have to just inline certain things. So this is up to, you never have to worry about going into the unit of work or even really interacting with it because you would be using the document manager. But the unit of work basically is responsible for keeping track of everything. And so the two important things are, one is tracking our database objects by their identifiers. So the goal with anything where we're managing database objects is that if we have product number 1 fetched from the database, we'd like to ensure in our application that there's only one instance of that object. So because if we want to be able to do change tracking, we want to make sure that there's only one object that we have to monitor changes to. So that's why it's important that we know what the identifier is so we can have them, and the object hash so we can make sure we have a map of what that is. And I have an illustration after to demonstrate that. But it also does all of the change tracking and the calculations for us. And so when it's done, when you're ready to flush, we have to look at all these changes and formulate what the database updates will be. And so the different objects in your application might have one of 4 different states. There's new things, which basically I just constructed this, so I haven't persisted it. So the unit of work doesn't know about it yet. Once I persist it, now it's managed, which means, or if I did a query and I got something back, it comes back to be managed. So this means that we're watching the changes to it, and when we flush, those changes are going to get written back to the database for us. Additionally, if we remove something, It means after I flushed, I deleted this from the database, but I still have this, the object still exists, it's just removed. So with that, you should probably stop using the object. And then if for some reason you had a managed object and maybe you want to serialize it or stop tracking changes to it, you could just detach it from the unit of work, which is basically saying, give me, this is the model I fetched from the database, and just forget about it. I'd still like to work with this model, but just outside of any database context. And so in PHP, when we construct a new user, it's new. Persisting it, it becomes managed. And if we were to remove it, we can flush it. And then there's also a detach method. But these are the most three common ones. So the purpose of one knowing what what their SPL object hash is, what the unique objects in PHP are, and what the mapped identifier field might be. So when we issue a query, the first thing the finder is going to do, we're going to say, find me user one. So this is with no other criteria other than just the identifier here. And so we do that. The first thing we do is we consult the unit of work. We say, are you already tracking, say, person with ID 1? If you are, I just would like, I'm not even going to talk to the database. I'd just like to get that object back. And so this ensures that there's only one person, number 1, existing in the application. And then if we're modifying it, we're modifying the same object, and we're tracking all the changes to it. If you have detached users and things like that, that doesn't include. But these are just for things that are managed. And if we aren't already tracking a user 1, we're going to actually run the database query. Or if maybe we came in with some criteria where find user Jeremy Mikola, we're going to run the database query. We come back. The first thing we do is this is the identifier, and we're going to start tracking this, manage this object by the identifier, just to make sure that there's only one instance of it. And so in this case, if you had the same manager, because each manager tracks its own objects. So if we did two different queries and both found the same user, we could expect them to not only be probably equal, but strictly equal, which means that they're exact same object. So this is basically one thing that you can rely upon than using any kind of object manager. And so the methods we might find here, a very basic find method to just find something by an ID, not the complex query stuff. They're things to change the state so we could remove things, detach them, persist them, flush to get all our changes. Clear basically says detach everything, or detach just everything of a certain class. And then the merge is interesting. That's for taking, I have this object, I'm not sure what the state of it is, so I'd like to give it to the manager and get back a managed version copy of it. So I'm actually I might end up getting back the same values inside, but now the object itself just happens to be, it might actually point to a different object that's managed. So I could talk a little bit about that after. And refresh is basically revert all my changes back to whatever the original database state was.
Does it go back to the database?
With refresh, it does not. So the only way we go to the database is when we do a flush, and that would just be for normal changes by altering fields or setting fields or things like that.
So it stores the original state?
Yeah, so unit of work is basically for each of our objects, we're tracking anything that ends up changing. And that, when we go to flush, if there are no changes, we might have thousands of documents, no changes, you might flush and there's really nothing to talk to the database for. Like if you set my username to, if it was originally A, you set it to B and then back to A, the ultimate change set is 0. Yep. And the different events that you might listen on, these are basically, as we're updating objects, loading them, flushing them. So these are what a great example of this is just having a behavior to update a timestamp field whenever you update an object. You just have a created at, updated at. So I might have an event listener on user objects that says, whenever I persist for the first time, if there is no created at field, initialize it. And every time I do an update, I just want to bump the updated at field to the current time. So you could use these for all sorts of things. 5 minutes left. So the event notification, basically things happen, and the event manager does the dispatching. And in the spirit of keeping things separated, the event manager, when our listeners can really be things like closures or methods. The listeners really don't have to know about the database either. They just have to expect that if you're listening on a persist event, you'll expect maybe whatever model you're listening to come into you. But you're not necessarily going to know that it's involving the database or anything like that. So you have listeners that maybe just tweak little fields inside of a model and really don't do anything with the database. You might have listeners that are more complicated that do want to work with the database that maybe like for auditing or other security things like that. And so there's two ways to, you could either add a listener directly on a certain event or have this generic subscriber that basically listens on multiple things. But this is actually a completely separate library, so even outside of the other projects use this just to do general event stuff. The object repository is the other thing that you'll frequently interact with, this query and the manager. So here this is the default methods, and then there's, you could have extra complicated ones that find one by username and create your own. And I think there's also, not in the original interface here, this is just the common interface. But in the actual ORM and the ODMs, there is a magic method that if you, to inflect what your actual extra method name is and build the criteria for you. So you might have find one by username, and it knows to do a where username equals whatever my argument is. But the object repository, you'll typically extend that for each model if you have your custom query methods in there, and you can just create specific methods to share with the rest of your team or your developers. And the query is really just, it abstracts the database API. So if you don't want to write SQL queries, or if you don't want to write raw MongoDB query criteria objects, you can use the query builder API. And there's other goodies added here, things like filters. So you might want to make sure that if you're using the query builder, you never fetch a user where the isDeleted field is true. So you could have filters that just get applied to all queries just behind the scenes. And then additionally, there's behaviors where if you want to control things like fetch mode, every time I fetch a user, I go and fetch the relationships. I do that join query to avoid the n+1 issue. Or control things like maybe I don't want to hydrate things back to an object. I just like the raw data back. So that a lot of that is exposed there as well. And so an example of this in PHP. So this is using Doctrine's, we call it DQL. So it's like SQL, but it's a little more abstracted. And so Doctrine ends up converting it down to the different nuances and syntax between the different database vendors. It does that for you. But it looks a lot like we inject our parameters just like PDO. And then a more, writing less SQL, but more, this is more what the MongoDB version looks like as well, is just you have methods for everything to select your field and then say if it's equal to or not. Just about out of time. This is the actual grammar, which you don't have to worry about, but trust that it is being maintained. And an example of using DQL to query like all the logic behind like a Facebook post or a wall post. And so one of the benefits here is that when we're selecting, we're working with our entities, so we don't have to think about the actual table names or anything, or the database names. We can use the mapped field names. And then relying Doctrine is actually going to tokenize and parse all this into an actual SQL query, with the benefit of caching it because we don't want to have to parse that every time. So some of the things that added on top of that are caching at different stages. So maybe database results, caching all that parsing of all of your SQL queries. With regard to change tracking, so by default, you might be thinking if Univ is tracking every time a field changes, then get really hairy with tons of fields. So the default policy is to actively try and track all the changes to objects, but there's more explicit ones where Univ doesn't track anything. It's the responsibility of the model to trigger a listener or an event that says these fields actually changed. So it's up to you. For more performance-intensive applications, you might want to explicitly say, this is what changed, instead of having the monitoring process have to pick it up. The other neat thing is proxy objects. So if we have a reference from a user to a friend, and we know what that friend's ID is, we'll create an object basically with that identifier, but without actually fetching any of the fields for it. And then if you go into that, if you decide to access that relationship and then try and access some field other than the identifier, we know, OK, now we have to hit the database. So this could be a nice way to work with related objects without actually having to load them up until you need them. And that works nicely with fetch modes that we might have actually done the join query and gotten the related data, but we're not actually going to hydrate it just yet. Okay. And then just the tour of some of the other packages. I'll have you out of here in a minute. So the common library is basically everything above there is not really related to the database, but it's used by a lot of the projects. So you have things like collections, which are just like an object-oriented array. So we use those extensively. There's the annotation library, which a lot of other frameworks are using. Inflectors for doing like pluralization and stuff like that. And the database stuff down below, so we have dbal, which is just abstracting. Essentially, it abstracts PDO and the other SQL database drivers. There's one for MongoDB and CouchDB both abstract those specific drivers. And then below that, we have the ODM or the ORM. And on the far right, the PHPCR is just a CMS repository for basically like Java's Jackrabbit, more Java jokes there. And that they all implement, since the ODMs and the ORMs all implement these common interfaces. So, and they're all available in Composer. So I'll stick around after. These are just a tour of some of the different interfaces. I don't want to hold anyone up. So the parting note is that, because I think one of the next sessions is explaining why we don't need ORMs. So the one parting note from Martin Fowler is that ORMs are great for, no snake oil salesman is going to pitch ORM as the solution. Well, some might, but I won't. Pitch it as a solution to all your problems, but they will get you the 80 or 90% there, but it's not an excuse to forget about working with the database. The one, reference one other thing to look up is ORMs don't kill your database. Developers do. And this is by one of the Doctrine guys, which is a great presentation on using an ORM responsibly. And so you could probably find that on Speaker Deck. But thanks a lot. This is some resources, all hosted by Server Grove. Thank you. And we're also on IRC. Thanks.